Good afternoon, everyone.
Eyes 1. Data structure and algorithm. Branch CSE. Division B. Name. Sanjit Kumar Das. Ajit Gamayar. PRN. 1,903,135. 1,903,133. Warm welcome to you all. In this session of animation presentation, we are here for presenting our animated video about data structure. We have tried to make the concept clear by preparing the conversation between teacher and student and by others' animations. Without doing any delay, let's start.
Good afternoon, student.
Good afternoon, ma'am.
Remember what we have read yesterday?
Yes, ma'am. You have start data structure.
Okay then, let's start.
Okay, ma'am. Ma'am, why we were here? You have told to teach about data structure, right? Or about Amazon jungle. Hehehehehehehe.
Shut your mouth off. But you are right. Not about Amazon jungle but about tree. Tree data structure.
Oh,
Okay, now listen carefully about tree data structure.
Tree. Data structure. True data structure. It means tree data structure is similar to our tree as all of its parts are divided in the pattern of tree. Tree is a most important data structure. Trees are hierarchical data structure. Arrays, links list, stack, queue or linear data structure. Properties of tree data structure. Every tree has a special node called the root node. The root node can be used to traverse every node of tree. It is called root because the tree originated from root only. If a tree has n nodes, that the numbers of edge is always one less than the number of node. Every child has only a single parent, but parent can have multiple child.
Okay, but why tree is opposite?
Because classification of tree data structure starts from root as main.
Root. Main. What it mean? Yes. I am feeling sleepy what you are saying.
Okay, then let's take one real example to get clear.
Okay, let's see.
Let's make the tree data structure of vehicle. Vehicle. Two-wheeler. Four-wheeler. Regular. Expensive. Now let's compare this tree data structure with our inverted tree. Vehicle. Two-wheeler. Four-wheeler. Cycle. Bike. Regular. Expensive. Car. BMW. Root. Branch. Branch, edge, fruit. Fruit, node, leaf. Leaf node. I think now you got why tree is inverted. Also, one main point is that this type of data structure can't be represented by array, linked list and stack. We have seen and become clear about our data structure formatty and why it was like that. Now let's move forward and see some types of tree data structure. Types of tree data structure. General tree. Binary tree. Binary search tree. AVL tree. Red-black tree. An tree. Let's look about these trees in brief. General tree. The tree is called a general tree when there is no constraint imposed in the hierarchy of a tree. In general tree, each node can have infinite number of children. This tree is subset of all types of tree. The general tree. Binary tree. Binary tree is the type of tree in which each parent can have at most two children. The children are re_fertilized to as left children or right children. This is one of the most commonly used tree. Fig binary tree. Binary search tree. Binary search tree is an extension of binary tree with some added constraints. In BST, the value of left child must be smaller or equal to the value of its parent, and value of right child is always larger or equal to the value of its parent. Fig binary search tree. AVL tree. AVL tree is a self-balancing binary search tree. This was the first dynamically balancing tree. In AVL tree, each node is assigned a balancing factor based on which it is calculated whether the tree is balanced or not. The common operation like lookup, insertion and deletion takes so long time in AVL Tree. AVL Tree. Red-black tree. Red-black tree is another self-balancing tree. The name red-black is given to it because each node in a red-black tree is either painted red or black according to the property of the red-black tree. An array tree. In an _array tree, the maximum number of children that a node can have is limited to n. A binary tree is 2 array tree as each node on binary tree has at most 2 child. A full n_array tree is a tree in which children of node is either 0 or n. Fig n array tree.
We have seen some basic about tree data structure. Now we will see different advantages and basic terms in data structure.
Okay, mom.
Before moving forward, be remembered that why a structure is as inverted tree and its types of tree data structure.
Remembered, mom. Clear what you have explained.
Okay, then now we will learn about advantages and other basic terms.
Tree. Let's see some advantages of tree data structure. Tree reflects in the data structure connections. The tree is used for hierarchy. It offers an efficient search and insertion procedure. Let's learn about some basic terms. Height of node. Height of node is the number of edge on the longest path between the node and the leaf. Height of A. 1, 2, 3, 3. Height of B. 1, 1. Height of C. 1, 2, 2. Height of leaf node. 0. Leaves of node. Leaves of node represents the node connection between the node and root. It represents the generatio of node. If the root node is at level 0, its next node is at level 1, its grandchild is at level 2 and so on. Level 0, level 1, level 2, level 3. Depth of a node. While talking about the height, it locates a node at bottom where from depth, it is located at top which is root level, and we called it a depth of node. In figure node G depth is 2. In depth of node, we just count how many edges between the targeting node and the root and ignoring the directions. Depth 0, depth 1, depth 2, depth 3. Now let's see some important terms. Path, root, parent, child, leaf, subtree, visiting, traversing, leaves, key. Definitions. Path. Path refers to the sequence of nodes along the edges of a tree. Root. The node at the top of the tree is called root. There is only one root per tree and one path from the root node to any node. Parent. Any node except the root node has one edge upward to a node called parent. Child. The node below a given node connected by its edge downward is called its child node. Leaf. The node which does not have any child node is called a leaf node. Subtree. Subtree represents the descendants of a node. Visiting. Visiting refers to checking the value of a node when control is on the node. Traversing means passing through nodes in a specific order. Level of a node represents the generation of a node. If the root node is at level 0, then its next child node is at level 1, its grandchild is at level 2, and so on. Key. Key represents a value of a node based on which a search operation is to be carried out for a node.
So students, today we have see about tree data structure along with its types, advantages, properties and other basic terms. And I wish that you have understand what I have explained.
Yes, mom. Understood.
Great to listen that. Now it's almost time to end this session. Thank you everyone for listening this explanation patiently. Now we will end up this session. Thank you everyone. Have a great day.
Okay, mom. Off. Finally finished.